I'm going to do an example using the multiplication rule and conditional probabilities. The example is, out of 350 flights, 315 depart on time, 301 arrive on time, and 294 depart and arrive on time. So this first part, we want to find the probability of a flight departed on time given it arrives on time. And B, we want to find the probability that a flight arrives on time given that it departed on time. So it may sound like those are the same problem, part A and part B, but they're actually not. So what we want to do is we first want to summarize the information. All right, so it says out of 350 flights, 315 departed on time. So the probability that a flight, given that information, a flight departed on time was 315 out of 350. And it says out of the 350, 301 arrived on time. So the probability of arriving on time would be 301 out of 350. And then the intersection would be the probability that a flight departed and arrived on time. So that was given to be 294 out of 350. So we want to use the multiplication rule that says the probability of A and B occurring is the probability of A given B over the probability of B. So the tricky part, I think, for these problems is trying to figure out what A and B are. So for part A, we're asked to find the probability a flight departed on time given that it arrives on time. So using the multiplication rule, the pieces of information that I'm given the intersection, okay, given A and B together, so that's 294 out of 350. What I'm asked for is to find this conditional probability. I'm asked to find the probability a flight departed on time given that it arrives on time. So this is the mystery value. And we're told that it arrives on time. So that is the probability that we're given. So that's going to be the denominator. So the probability it arrives on time is 301 out of 350. Okay, so all you have to do is isolate this probability of A given B. Very easy to do. I'm just going to multiply by the reciprocal of this denominator. So it'll be 350 out of 301 times 294 out of 350, and that'll be equal to the probability of A given B. So on this side, the 350s will cancel, so we're left with 294 out of 301, and that'll be the probability that the flight departed on time given that it arrived on time. Okay, so again, if probabilities are dependent, your sample space is going to be reduced, and we see that here. The denominator is not the full 350. And again, we can convert that to decimal if you want, if asked for in a homework problem, for example. And you do want to double check that your answer is actually a valid probability. And this is. Okay, remember, a valid probability has to fall between 0 and 1 inclusive. Now for the second part, we want to find the probability that a flight arrives on time given that it departed on time. So again, using this relationship, probability of A and B is equal to the probability of A given B over the probability of B. In part B, we're given different information. We're given that it departed on time. So that denominator on this side is going to be the probability corresponding to departing on time, whereas part A, the denominator was corresponding to the probability of arriving on time. The left side is going to be the same. It's going to be that intersection, which is 294 over 301. So what A and B represent now are different in this problem. So I can still use A and B as my notation, okay? But what I want to make sure is I want to make sure that my event in the denominator represents the event that's given. So we're given that the flight departed on time, and the probability that occurred was 315 out of 350. Again, resolving by multiplying both sides by the reciprocal. Oops, this denominator is... I am so tired today. Okay, this is 294 out of 350. My apologies. Okay, I was copying from my previous step when I should have been copying from my original intersection. Okay, again, multiplying both sides of the equation by the reciprocal of this denominator, I have 350 over 315 times 294 out of 350, and that's going to be equal to the probability of A given B. Again, we can have these two values cancel, and then we have 294 out of 315. So that will be the probability that a flight arrives on time, given that it departed on time. So you can see parts A and parts B, the answers are not the same. So this means that we've got dependent probabilities. If we could switch those and end up with the same probability with respect to the probability of A and B by themselves, then we would have independent probabilities.